of the compounds NOF and NO2F, one has a dipole moment of 1.81 dBi, and the other has a dipole moment of 0.47 dBi. Which dipole do you predict for each compound? This is a nice question, because they both have dipoles. It's not like one's polar and one's nonpolar. They're both polar. The question is, how polar? So if we look at this, let's look at NOF to start with here. What will be the center atom in NOF? Which has the lowest electronegativity, nitrogen, oxygen, or fluorine? It's nitrogen, isn't it? So we have nitrogen, and we'll put fluorine over here and oxygen over there. Now, NO2F, nitrogen's also the lowest electronegativity atom there, so we'll put an oxygen, and a fluorine. If we count the electrons, we have 7 and 5 and 6, and that's 18 electrons, right? So that's 18. So if we put single bonds here and here, that's 18 minus 4 is 14. So we have 2, 4, 6, 8, 10, 12. 14 minus 12 is 2, and we put 2 electrons here, but the nitrogen's still short. So we've got to make what? A double bond. Got to make a double bond, so we'll put it in there, and then we have something that looks like this. Okay, what is the shape class of the nitrogen in this compound? AX2E. AX2E. If you look at these bonds, this one is no doubt polar towards the fluorine. Fluorine's the most electronegative atom that we know about. And oxygen is second, certainly more electronegative than nitrogen. So we have 2 polar bonds and a lone pair. And they're going to be, AX2E is bent, right? Or angular. So we have this kind of a situation. It's a lone pair here. And so we have 2 bond dipoles like this. The net dipole is going to be down this direction somewhere. Okay? So this is going to be a fairly polar molecule because you've got 2 bonds and they are set up in such a way that their vertical parts will add to one another. So this guy will be fairly polar. Let's look at this one over here. Now we have 24 electrons. And I'm going to put in my single bonds. Here are my single bonds, 3 of them. So that's 6 electrons. And that leaves us with 18 electrons. So we're going to 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 minus 18 is nothing. But the nitrogen is short. It only has 6 electrons around it, so what do? Make a double bond. We can make a double bond from either one of these oxygens. So we make a double bond this way, put it there, what we get looks like this. That little mark there is nothing. Okay, so now we have a molecule that has 3 polar bonds in it. This one is polar this way, this one's polar this way, that one's polar that way. What will be the shape of the molecule? What's the shape of this guy? What's the shape class? AX3. And that means trigonal planar. Okay, so we have 3 bonds that are trigonal planar, and the bond vectors, the NF one ought to be a little bit larger than the NO ones. So these things will partially cancel, but not completely cancel. If this was some sort of an NO3 molecule where all the nitrogen, all the bonds for nitrogen, oxygen, it would cancel. But there isn't any such thing just like that. There's an ion, but we don't talk about whether ions are polar or not. So in this case, mu should be not 0, but it should be small because these NO bonds vectors almost cancel the NF bond vector. They're sort of all pulling away roughly at 120 degrees. So we would figure this mu over here was large because of the bent shape and the polar bonds, but this one should be not 0, but small. Everybody see the distinction? Can you think that through all right? Does it make sense to you? So I would judge from this that this one has 1.81 dBi, and this one has 0.47 dBi. How are we doing?